So here we can see in example 2, we have a hyperbola that does not have a center located at 0, 0. All right. So as we look at this one, keep in mind that h is connected to y, or h is connected to x, and k is connected to y. All right. So based off of this hyperbola, since the y is first, that means what? Y is first. It'll have a vertical transverse axis. All right. So it will be oriented vertically. So the branches of the hyperbola will open up and down. All right. But in this case, this will give us the value of k. So the y-coordinate of the center will be located at -1, and the x-coordinate we'll get from here, which is the value of h, which will be +4. Remember, again, our rule inside opposite. So the center of the hyperbola will be at 4, -1. Down here. Okay. Because h is always with the x. And k is always with y. All right. Again, a squared and b squared are locked in. So this 16 is a squared. So if that's a squared equals 16, a would equal 4. And for b squared, that's going to be 4. So if b squared is 4, b would equal 2. All right, so now we have enough information where we can go ahead and plot those points. And again, if you want to box it up, you can, but ultimately you just need the corners of the box to draw in the asymptotes, so it's up to you. We do know, again, that this has a vertical orientation, vertical transverse axis, so we will count up and down the value of A. All right, so we're going to count 4 units up and down. So again, the counting can get a little bit more complicated here because we're not at 0, 0. So if we go up 4, 1, 2, 3, 4, one of our vertices will be at 4, 3. Okay. And then if we go down 4 units, that one will be at 4, -5. Okay. Now for the endpoints of the conjugate axis, we will count to the left and right 2 units. So 1, 2, and 1, 2. So those endpoints are at 2, -1, and 6, -1. All right. So now we do have the endpoints of our, or we can find the corners of the box. You can just think about where they're going to meet. So it would be there, there. So I'm going to draw the asymptotes through those points. Again, if you want to make the whole box, feel free to do so. If you would rather just make the corners, that's fine too. All right, and draw in those asymptotes. You can see here that this will be more complicated as far as expressing those equations, because it's not at 0, 0. But we'll talk about how we can handle that, and won't be too terrifying, I don't think. So there are our asymptotes. Now, is the transverse axis vertical or horizontal? Vertical, because y is first. So our hyperbola will open up and down. We'll start here. This is a vertex. So it'll look like that. And this is also a vertex. You may want to label them initially, like if you put that this is a vertex and a vertex, that might be helpful for you. Okay. So feel free to do that if you feel the need. That way you don't forget. Okay. So the hyperbola is plotted. Feel good. We have the center. We have the vertices. So that's all good. It asks us for the transverse and the conjugate axis. All right, so that's like saying the equation of them. So we can provide that real quickly. The transverse axis is right here. All right, it goes through the vertices and the center. It's a vertical line, so that would be, if it's vertical, it'll be x equals, and what's the value of x anywhere on that blue line? Yeah, x equals 4. Okay. Now, the conjugate axis goes through the center and those endpoints of the conjugate axis. That's a horizontal line. That horizontal line is going to be y equals, and it'll be y equals -1. Okay? So we're good there. So now we have 2 items to find. We have a graph already. We can find the foci and the equation of the asymptotes. We'll do the foci first. So for the foci, we know that it will be on the transverse axis. So again, we can utilize our bizarro Pythagorean theorem. The value of c, since a squared and b squared are the same as the last example, right? It's going to be the same thing. So it's c squared equals 16 plus 4. So c will come out to be 2 root 5 again. So as far as our foci are concerned, they will be, whatever that 4.4-ish, right, away from the center, and they will be arranged vertically. So they'll be somewhere like here and here. All right. So what value is getting impacted there as you move from the center, x or y? Y, because we're going up and down, right? So our center is at 4, -1. All we have to do, since the x value stays the same, is write that as -1 for the y coordinate, and then plus or minus 2 root 5. Because that's just signifying that from -1, we're going to go up 2 root 5 and down 2 root 5. All right. Now, if that value of c was a nice clean integer value, like if c was 5, then I would expect you to write it out in 2 separate coordinates. Okay, so if it's a nice clean integer, just like with the vertices, how I wrote that out as 2 separate coordinates, I would expect you to do the same thing for the foci. Cool? All right. So the only other thing that we have to talk about then is the equation of the asymptotes. All right. What point do the asymptotes have in common? They have the center in common, right? They have 4, -1 in common, right? Okay. And then to find the slope, again, it's just going to be a ratio of a and b, and it'll be plus or minus. One asymptote will have a particular slope, and then the other one will just be the negative version of that. All right. Count will run here again from the center. We would go up 4, right? And to the right 2. So 4 over 2 gives us 2. Okay. So the slope here of that would be plus or minus 4 over 2, which is plus or minus 2, correct? Okay. So we have a point that it goes through, which is not 0, 0 in this case, and a slope, right? So when the center was at 0, 0, we just said y equals plus or minus the slope because the y-intercept was 0. Here the y-intercept is not 0. They have 2 different y-intercepts, don't they? Those asymptotes, you got a y-intercept up here and a y-intercept down here. We can condense this, and I will allow you to just leave the answer in point-slope form. So point-slope form, if you remember, was this. All right. So what we can say for the equation of the asymptotes when the y-intercept is not at the center is y, this would be y minus y1, which would be y minus -1. So that would be y plus 1 equals our slope of plus or minus 2, and then x minus 4. And that would be your equation of the asymptote.